Okay, the other type of inequality we're going to look at today is a quadratic one. Okay, we're going to use the same kind of idea to determine the answer to this one as well. Okay, we're going to use the techniques that we learned dealing with quadratic equations, okay, to do it. Okay, and we're going to start out by considering it just like an equation, which means we're going to get it in the standard form, and hopefully it either factors or we can use the quadratic formula. Okay, again, here you might say, can we use completing the square to find the solutions? Yeah, you could, but I would suggest, especially like I said earlier, if there's an a value here that's not 1, okay, that completing the square is more work than it needs to be. Okay, so I would stick with mainly factoring and quadratic formula. Okay, but what it boils down to is if I take a look at this equation in this form, okay, remember when you're taking the ACT test, once again, if you have this problem and you say, well, crap, I can't remember how to solve a quadratic inequality, okay, remember, do you need to remember? Because what are we really asking for here? When is this parabola greater than or equal to 0? In other words, when is it above the x-axis? Okay, y equals 0 is just the x-axis, isn't it? Okay, all we want to know is in this picture, when is this parabola above the x-axis? That's all we're asking. And if you have a graphing calculator, do you really need anything else to find the answer? So looking at it from a graphical standpoint first, if we do our 5x squared minus 11x minus 12, we can see the answer, we'll need those 2 points right there, and of course we could find those with our 0 command. But then the answer to this, again, is where is it greater than 0? Okay, our answer is going to look something like this. And I have the 2 answers here. We'll show how to get those in a minute. But our answer, without having, as long as we could find those 2 points, we know it has to look like this, don't we? Because we're asking for when it's above the x-axis. It's going to be above it from negative infinity until we get to this point, which turns out to be negative 4/5. And then it's going to be above it again after 3. So 3 to infinity, it's going to be above the x-axis. Okay, so as long as we knew these 2 critical points right there, then we could write this right away, couldn't we? Okay. Had this been a less than sign, then instead of this, it would have been between negative 4/5 and 3. Okay? So the key issue for us in this problem is really just finding those 2 points. Okay? Well, luckily for us, what did we just spend P6 doing? Okay? We learned how to find solutions, P5 I should say. We learned how to find solutions to quadratic equations. Okay? So in this particular case, we can try to factor this if we want to. Okay? And it does in fact factor. I use the AC method, which I'll illustrate again here, so you have it again. You can use trial and error if you want to start out with 5x and x and then just plug in factors of 12 here and try to build the 11. Negative, you can. Otherwise, the AC method, remember, is to multiply the a times the c, 5 times negative 12, gives you negative 60. And then write down the factors that will give you negative 60, negative 1 and 60, 1 and negative 60, and so on, until you find the one that adds to give you negative 11. Okay, which happens to be this one. Okay. And then from there, what we want to do is take the middle term, which is negative 11x, and rewrite it as the 2 that I just found from my list, negative 15x and positive 4x. Okay. And just a hint here, notice I wrote the negative 1 first. If there is a negative 1, I would always write the negative 1 first, okay, because it makes the factoring in the next step a little easier. Okay. It can be done either way. Okay. But then once we group the first 2 and group the second 2, okay, and if we look at the first 2, they have a greatest common factor of 5x. If we factor that out, we get x minus 3 left. These 2 have a greatest common factor of 4. If we factor that out, we're left with x minus 3. And you notice that these 2 parentheses are what? They're the same, which is good, because that's one of our factors. The other factor comes from what's out in front. So the 5x and the 4 you have out in front make the other factor. Okay, and if you don't believe that's true, you can FOIL this. And if you FOIL it, you'll get back to what you started with, which means that your factorization is right. Okay? And then, of course, once we set each of these equal to 0 and solve, we get negative 4/5 and we get positive 3. Okay? And again, those are the 2 critical points that we saw in the graph. And we know that since we want greater than, okay, that it's going to be negative infinity to the first one, and a union of that, and in 3 down to infinity. Okay, or over to infinity, I should say. All right, questions on that process? All right. One more example using a similar idea to that. is this problem. They give us this projectile motion equation. It tells us that S is going to be the height of an object that we launch from the ground or from wherever we launch it. Okay, this negative 16t squared term, notice, is always there. Okay, this v sub 0 in front of the t is going to be our initial velocity. And this s sub 0 is going to be our initial height. Okay, so we're going to use this equation, and notice it's a quadratic equation, so the graph is going to be a what? Okay, and what do we call that in math? That's a parabola. Okay, so the graph is a parabola. And notice that it's got a negative leading coefficient, which means it's going to open down, which shouldn't be surprising if we're launching an object up in the air. It's going to go up and come back down. True? So that's the model that we're going to use. And in this particular case, they told us that the projectile is launched straight up from ground level. Okay, ground level, notice. So our initial position, they told us, is on the ground. And the initial velocity is 288 feet per second. And we want to know when will the projectile's height be above the ground, 1,152 feet. Okay. So the first step is going to be, let's write the equation. So if we write our equation, S sub 0 is going to be 0 because we're firing it from where? The ground. They told us the initial velocity is 288, and so hence the equation is going to be still negative 16t squared. That's always there. V sub 0t, 288t, and S sub 0 is 0, so we don't have a constant term in this case. Okay. Now, with that said, okay, what we really want to figure out here in part A is determine when, okay, at what time does S become 1152. So if we plug in 1152 into this quadratic equation, that's exactly what we have, is a quadratic equation. And if we were to graph it, guess what we'd see? We'd see a parabola upside down like we thought, and then at some point it's going to cross that line 1152. Okay? And can we find these 2 points? Sure. Okay? And we can find them by several different ways. We could graph this, and we could use the intersect command. That's one way. Okay? We could take this, and it turns out that if we factor a 16 out of this, it turns out to be some decent numbers that we can use. And it also turns out that this one actually factors. Okay? And we can find the two answers are 6 and 12. Again, we can find them the same way with the calculator. Okay? And so time 6 and time 12 are going to be the times when this object is at 1152. And remember, it's there twice, okay, physically, because it's going up and it hits 1152, and it's going to hit 1152 again when it comes down. Fair enough? Okay. Could there be no solution to a problem like this? What if I said, when is it at 10 million feet? Okay. Would there be a solution to this then in that case? No, because at some point it's going to reach some maximum height, true? So if that 1152 would have been higher than the maximum height, like up here, like I have drawn, okay, would we have had solutions to this quadratic equation? Okay. What would the determinant have been? What would the determinant have to have been like if we had non-real solutions? If there hadn't been a real answer to this? Okay. What kind of determinant gives us imaginary solutions? And negative determinants give us imaginary solutions, wouldn't they? So had this been a number bigger than the maximum height value, okay, and we tried to do this, we wouldn't have been able to factor it probably, and we also would have recognized that the discriminant was negative. We would have gotten some i's in here, okay, because there is no real solution if it would have been way up here. True? So it's possible that there could be no solution. Okay. What if they had asked us when is the projectile above 1152? When is it above 1152? Okay. Wouldn't it be from here to here? So how would we express that in interval notation? We'd say from 6 to 12. Okay, from 6 to 12, it would be above 1152, wouldn't it? Okay. So by saying when is it above, I just made it, instead of an equation, it was now an inequality, wasn't it? Questions? Okay. So